Okay, so this is the third part of the video, and we're going to go through question 11 to 15. So first of all, we've been given a function here, and we want to prove that it is a factor of f of x. Probably the easiest way to do this is just to use the factor theorem. Now, the factor theorem says that if you substitute in the negated version of this, it should be equal to 0 if it is a factor. So for 11 part A, I'm actually just going to work out what f of 4 is, because the negated version of negative 4 is 4. And I'm just going to substitute into the function, which is 2x cubed. So it will be 2 times 4 cubed minus 13 times 4 squared plus 8 times 4 plus 48. So I'm pretty confident this is going to be equal to 0, but I'll just show you on the calculator anyway. 2 times 4 cubed minus 13 times 4 squared plus 8 times 4, plus 48 is equal to 0. So you need a concluding sentence to say, hence, x minus 4 is a factor of f of x. You could use polynomial division here, but I think the factor theorem is the most efficient way to do this. Part B of the question says, hence, using algebra, so you must use algebra to do this, show that the equation f of x equals 0 has only two distinct roots. So distinct meaning different here. So I'm going to take f of x, which is 2x cubed minus 13x squared plus 8x plus 48, and I know that x minus 4 is a factor. So I'm going to do some polynomial division here. I'm going to divide 2x cubed minus 13x squared plus 8x plus 48. I'm going to divide it by x minus 4. There are other methods you could do for this. This is just what I would do. So I have to multiply this by 2x squared to get 2x cubed. So that would be 2x cubed minus 8x squared. When I subtract these, I would get minus 13 minus 8. If you're not sure about this, minus, let's put this back over this side. Goodness me, it's not playing ball. Minus 13 minus 8 is obviously negative 5x squared. I didn't even need the calculator. And I'll pull down the 8x as well for a second. So what do I have to multiply this by to get here? Well, minus 5x. So that would give me minus 5x squared plus 20x, and then I'm going to subtract. 8 minus 20 is minus 12x, and I'm going to pull down the 48. And to get to minus 12x, well, I need to multiply the x by minus 12. So I get minus 12x plus 48, and I get 0. There's no remainder. So this tells me that f of x can be written as x minus 4, 2x squared minus 5x minus 12. And I'm going to keep seeing if I can factorize this. Now this is actually going to factorize to x minus 4 and then 2x plus 3. The reason I was able to factorize this so quickly is because the question says there are only two distinct roots. So I knew that one of the brackets was going to have to be an x minus 4, otherwise there would have been 3 different roots. So that's how I was able to factorize that really quickly. And so I have x minus 4 squared, 2x plus 3. So if f of x is equal to 0, then we would have x is equal to 4, or x is equal to minus 3 over 2, hence two distinct roots. Part C of the question says, figure 2 shows a sketch of part of the curve. Deduce, giving reasons for your answer, the number of real roots of the equation. And the equation here is slightly different. And the thing that you should have noticed is this one is plus 48 and this one is plus 46. So because it's plus 46, that means that it has actually shifted down 2. So the transformation here is a translation 2 units down. Now, if you imagine this graph coming 2 units down, it would look something like this. This is not very well drawn. Let's try it a bit better. That's what it would look like if it came 2 units down. So how many roots would there be? Well, there'd be 1, 2, 3 roots of the equation, 3 roots of that translated graph. So I'm just going to write that down. What did they say? The second equation is the same as f of x equals 0, but has been translated 2 units down, meaning it will now intersect the x-axis in 3 places. So there are 3 roots to 2x cubed minus 13x squared plus 8x plus 46 equals 0, because it's moved down 2 places. So I didn't need to actually do any maths, just needed to think about what was happening. Part D then says, given that k is a constant and the curve with equation y equals f of x plus k passes through the origin, find 2 possible values of k. So at the moment, this is the roots that we've got are here and here. This is for the original equation. And the roots for the original equation, we said, were 4 and minus 3 over 2. So this is 4 and this is minus 3 over 2. And we've got some kind of transformation that's happening here. This time it's going to be a translation of minus k 0. So if I wanted it to go through the origin, I could try and make the 4, this point here, I could try and shift this graph so that it went through the origin, meaning that it would go 4 to the left. So I would want k to be equal to 4 here. So one of the solutions is that k would be equal to 4, because if it was f of x plus 4, it's going to go 4 to the left. Or I could take this minus 3 over 2 and I could make it move to the right. So this whole graph would move to the right. And that would be f of x minus 3 over 2. Because minus 3 over 2 is going to move it right to the space 3 over 2. So k could also be minus 3 over 2. Now, does it need a reason for this? It just says find the 2 possible values of k. So I don't actually need to give any reasons here. K is just either 4 or minus 3 over 2. And here we go for this question. So we've got factorizing, using the factor theorem to show that it's a factor, then polynomial division to come up with this. And you do need to say that there are a couple of roots there. We've said that it's 3 roots because it's moved down 2. And that's exactly what we said here. And then all you need is 4 and minus 3 over 2. If you've got them the wrong way round, if you've got a negative 4 and a plus 3 over 2, you'd only get 1 mark. But if you've done them both, you get the marks there. Okay. It's actually quite easy when you break it down and you start thinking about what the question is asking for. Okay, question 12 is a trigonometry question. So we need to show that the left-hand side here can be simplified to 4 minus 5 cos theta. So let's have a look at what happens. So I'm going to start with the left-hand side, and I'm eventually going to try and show that it's equal to the right-hand side. So I've got 10 sine squared theta minus 7 cos theta plus 2 all over 3 plus 2 cos theta. Now you'll notice there's no sine in the right-hand side. So I'm going to replace the sine squared with 1 minus cos squared from our Pythagorean identity here. And I'm going to divide that by 3 plus 2 cos theta still. Expanding the top, 10 minus 10 cos squared theta minus 7 cos theta plus 2. Don't know why I put brackets on the bottom before. I'm not going to do that this time. And then I'm going to simplify the top. So I've got 10 plus 2, so that's 12, minus 7 cos theta, minus 10 cos squared theta. And I've kind of written this quadratic in reverse here. You might see why I do that in a second. I keep putting brackets. It doesn't really matter if I do. Now, I want the thing I'm aiming for to not have a denominator. just is 4 minus 5 cos theta. So I'm going to want that denominator to cancel. And you can probably notice that this top half that we've got here is a pseudo-quadratic. It is a quadratic in cos theta. So there's going to be a clue here, because I want it to cancel with the bottom. I know that the top part has got to have that as one of the factors. So I'm going to be a bit cheeky and I can kind of cheat, and I know I'm going to have this cancelling. I'm just going to think about how this top is going to factorise. Well, the number is going to have to be a 4 in order to get the 12 that I have here. And in order to get the minus 10 cos squared theta, well, I'd have to multiply the 2 cos theta by minus 5 cos theta. So I didn't even need to really do the factorising. I used the information in the question and what they were aiming for to help me get there. And then I can cancel these bits out. So it is just 4 minus 5 cos theta, and I've then actually answered that first part of the question. Part B says, hence or otherwise, solve between 0 and 360 this equation. Well, you'll notice this thing that I have here is exactly the same as this thing, apart from x and theta have been switched. So that means that I can replace this here. So I'm just going to rewrite that now. I'm just going to say, instead of that yellow bit, I'm going to say it's 4 minus 5 cos x, not theta, is equal to 4 plus 3 sine x. They love doing questions where part A helps you do part B. There's that word hence that tells us that's going to happen. So I can subtract 4 from both sides, and I come up with this equation. And then I'm going to divide both sides by cos, so that I can create tan. So I get minus 5 equals 3 tan x. And then I'm going to divide by 3 to get that tan x is minus 5 over 3. So I'm going to do the inverse tan of minus 5 over 3, which is minus 59.04 degrees. But that's not inside the range. And for tan, to find the next solution, you just add on 180. So we get 120. Actually, let's do it to just one decimal place. So it will be 121.0 degrees. And then if I add on another 180, I get 301.0 degrees. And I'm just going to remove this one because it's not in range. So I just have these two answers, which is 121 degrees and 301 degrees. Let's see if that is the same as they got. So exactly the same process for this beginning bit, using this identity, factorizing, and then cancelling. And then here you got the tan is minus 5 over 3, and we got 121 and 301. If you ever see AWRT, it stands for answers which round to. So if you did a more detailed answer than that, but it's still rounded to that, then you would get the marks. Okay. Let's have a look at question 13. So this one is a really nice question. I like this one. So they've shown an equation here, which is y equals 2x cubed minus 17x squared plus 40x. And it says that it has a minimum turning point at x equals k. And we can see that on the graph. So as soon as I see something to do with turning point, I am thinking of differentiation. And then it says that the region shown is bounded by the curve, the x-axis, and the line with equation x equals k. So when they start talking about regions being shaded and area, I start thinking of integration. So I'm going to need to do both differentiation and integration here. But I don't want to do the integration just yet because the boundaries are between 0 and k, and I actually don't know what k is. So I'm going to try and find out what k is to begin with. So in order to do this, I'm going to differentiate it. dy by dx, if I differentiate this function here, I would have 6x squared minus 34x plus 40. And because it's a turning point, I know that dy by dx is going to be equal to 0. So 6x squared minus 34x plus 40 is equal to 0. And then I'm actually just going to use my graphics calculator, which does the simultaneous equation solver. It's not on this one that I've got here. So I'm going to go to my simultaneous equation solver, and I'm going to put in 6 minus 34 and 40. And it comes up with two solutions. I either have that x is equal to 4, or x is equal to 5 over 3. Now, that's weird that it's giving us 2. Well, makes sense, because there are 2 turning points. There's a turning point here and a turning point here. We want the minimum, which is the second one. So this one, because 5/3 is smaller, must be here, and this one must be 4. So we're not going to use 5/3. We're going to say that k is equal to 4. So all I need to do now is I need to integrate the curve between 0 and 4. Those are my boundaries, 0 and 4. And I'm just going to integrate and substitute in the limits. So I have 2x cubed minus 17x squared plus 40x with respect to x, square brackets. I'm going to increase the power to 4 and divide by the new power. I'm going to increase the power to 3 and divide by the new power. I'm going to increase the power to 2 and divide by the new power. And I'm substituting in between 0 and 4. So that's a half x to the 4 minus 17/3 x cubed plus 20 x squared between 0 and 4. Now you have to use substitution here. You can't just put the original thing in your calculator. This is what they want to see. So it will be a half multiplied by 4 to the power of 4 minus 17/3 multiplied by 4 cubed plus 20 multiplied by 4 squared. And you're going to be subtracting a 0 minus a 0 plus a 0, because when you sub 0 into all of those bits, you're obviously going to get 0. Now I know this thing that's in brackets here is going to be 256/3, but I'm just going to confirm that to you by typing it all in. So that is a half times 4 to the power of 4 minus 17/3 multiplied by 4 cubed plus 20 times 4 squared, which is 256/3. It's actually quite a simple question when you see it written down in this. It's a differentiation section and an integration section. So for this question, the marks are broken down like this. There are 4 marks for the differentiation part. 1 for trying to find the overall method, 1 for differentiating, 1 for solving the equation, and 1 for picking the correct value. Then you get 1 mark for doing an integration, a second mark for substituting in the correct value. You must do the substitution, and the final mark for coming up with the correct one. Okay, we are nearly there. I think I was saying 15 questions. I actually think there's 16 questions. So sorry about that. Okay, we're going to do question 14 now. It says the value of a car can be modeled by this equation that we have. So it's an exponential type of equation that we've got here. And you'll notice there is a negative here, which means that it is depreciating in value. The curve is going to be coming downwards. Where the age of the car is t years and the value is in v pounds. Using the model, find the initial value of the car. Initial value means t is equal to 0. So you're going to have, for this first part, see if I can get the formula in at the same time, that the value is going to be 15700 e to the power of 0 plus 2300. Well, e to the power of 0, anything to the power of 0 is just 1. So it's going to be 15,700 plus 2,300, which is £18,000. That's the initial value of the car. Didn't even need a calculator. It then says, given the model predicts that the value of the car is decreasing at a rate of £500 per year at the instant when t equals 2, show that this thing is true. Now, the thing I'm interested in the words that they've got here is that it is decreasing at a rate of £500 per year. So this is the rate of that something is changing. In other words, how is the value changing with respect to time? So we know that the value of the car is in the amount of, the value every year, it is going down £500 per year at a particular time. So I'm going to try and find out what dv dt is. V is equal to 15,700 e to the minus 0.25t plus 2,300. So I'm going to differentiate. And when you differentiate e functions, like e to the k, if you differentiate this, e to the kx, I should have said, you just get k e to the kx. You just bring down the coefficient of x, and we'll explore that more in year 13 maths. So I'm going to differentiate this, which will give the 15,700 will remain, and we multiply by minus 0.25, but the e part remains, and the 2,300 is going to differentiate away. Let's just simplify this a bit. So that's 15,700 multiplied by negative 0.25. That's minus 3925 e to the minus 0.25t. Now, when t is equal to capital T, dv dt is equal to minus 500. So I can say that minus 500 equals minus 3925 e to the minus 0.25 capital T, which is basically what they've got here, apart from both of their sides have been negated. So we can say, hence, 3925 e to the minus 0.25 capital T is equal to 500. And then part B says, hence, find the age of the car at this instant, giving your answer in years and months to the nearest month. A few people forgot that in my class. So really what this means is solve the equation. So the first thing I'm going to do to this equation is I'm going to divide by 3925. So e to the minus 0.25t is equal to 500 divided by 3925, which is 20 over 157. I'm going to try and keep it kind of accurate here. I'm going to take natural logarithms of both sides. If I take natural logarithms of this side, you just get left with the power, which is minus 0.25t. And if I take a natural logarithm of this side, I get ln of 20 over 157. Then to solve this equation, I can just do ln of 20 over 157 divided by negative 0.25. So let's just put that in my calculator. That's the ln of the answer divided by negative 0.25. And they've simplified it there for us, but I'm just going to do it as a number because that's what I want to use for it here. So t is equal to 8.242 blah 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 years. Remember, t was measuring it in years. So this is going to be 8 years, and we need to see how many months it is. So I'm going to take off the 8 years for a second. I've got 0.242 years. If I multiply that by 12, it will tell me how many months it is close to. So that is 2.9 months, which is going to be 8 years and 3 months to the nearest month. So to find out how many months it was, I did my 0.242. I multiplied it by 12 to change it to months there. So it's 8 years and 3 months. Then it says that the model predicts that the value of the car, approaches does not fall below £8. State the value of £8. Well, if we go back to the original model that we've got here, if you imagine t becoming very big, you're doing a number to a very negative number. Let's just do that as an example. Let's put in e to the power of something like, I don't know, minus 1,000. It basically becomes 0, which means this whole first section here becomes 0. So the value just goes towards this extra bit that has been added on, which is 2,300. So for that part C of the question, it is just going to be 2,300, or £2,300 is the value that it goes towards. And then for part D, it says state a limitation of this model. Well, this model doesn't necessarily take everything into account about cars. One of the main things that happens with cars when it ages is sometimes a car can become a vintage car, which might mean that the price of the car starts off going down, but then years later, people might want that car and it becomes really expensive again. So that's one of the reasons. I'm going to go with the model doesn't take into account that with age, the value of the car may increase like vintage cars often do. And you might think, oh, well, I don't know much about cars. So in a second, I'm going to show you some of the other answers you could have given here. So we came up with 18,000. You get 2 marks for differentiating it correctly. You get a 3rd mark for being able to make the thing that they wanted. Then you get the solving of the equation, and 8 years and 3 months, and we get the mark for 2,300. So here are some other reasons. You could say other factors affect the price, such as the condition or the mileage. If the car has an accident, it will be worth less than the model predicts. The price may go up in the long term as it becomes rare or vintage. £2,300 is too large for a car's scrap price. So if it came a long time, it's never going to go below 2,300. Most cars scrap for around £400. But it does say any suitable reason, so there are lots of other ones that you could give as well. Okay, we are nearly there. We're going to have a look at question 15, which is a proof question. So it says, given that n is a member of the natural numbers. Now, the natural numbers are basically 1, 2, 3, 4, 5. They're like the counting numbers. Some mathematicians think that 0 is in there, but some don't. But it doesn't really matter. So it's basically saying for the positive integers. And we're going to try and prove that n cubed plus 2 is not divisible by 8. Well, positive integers have this really good property of either being odd or being even. So we're going to try and do a proof that n cubed plus 2 is going to not be divisible by 8. So there's a few ways you could do this. You could say, if n is odd, then n cubed is odd, because any odd number cubed is also odd. Hence, n cubed plus 2 is also odd, and so cannot be a multiple of 8. Because obviously all multiples of 8 are even. So that's one of the ways of considering it. Another way that people considered this is they said, let n be an odd number, like 2m plus 1. So if n is equal to 2m plus 1, then n cubed plus 2 would be 2m plus 1 cubed plus 2, which actually works out as 8m cubed plus 6m squared. Hang on, that's not right. Plus 12, 2 times 2 times 3, yeah, plus 12m squared plus 6m plus 1 plus 2. This bit I just did by doing binomial expansion in my head, but not particularly well. And when I simplify this, I get this. If I take a factor of 2 out of the beginning terms, I get this. So I could then say this is even, but adding 3 makes it odd, so it can't be divisible by 8. Some of my students did this way, which I prefer. Some of them did this way, which I like, but it's more work. So we've dealt with the odd numbers, now let's deal with the even numbers. Let n be even. Well, you've got to be careful, because with even, if we go through the same logic, if n is even, n cubed is even, and n cubed plus 2 would also be even. So it doesn't show that it can't be divisible by 8. So we are going to have to use a different method here. We're going to let n be an even number. So we're going to say that n is equal to 2m. So n cubed plus 2 would be 2m cubed plus 2, which is 8m cubed plus 2. And this is 2 more than a multiple of 8, because of this bit is clearly a multiple of 8. This is 2 more than a multiple of 8, so it cannot be divisible by 8. Hence, if n is a member of the natural numbers, n cubed plus 2 is not divisible by 8, because we checked it for the odd numbers and we checked it for the even numbers. Okay, so it's a bit of a tricky proof here. We haven't done much proof in my class, so I would be surprised if people are able to do this one. But I'll show you the mark scheme, because there's a couple of other ways that people could have done this. There's quite a few ways of doing this proof. So here we go, we came up with the same bit as before. If n is even, they used k instead of m, so they've said it's 2 more than it. And if n is odd, they came up with the same expression that we had here, and they said it's an even number, add 3, so it's not divisible by 2. There are other approaches that I have here, which I will leave for you to have a look at. And I think embedded somewhere else, I'm not sure if I actually like the way that we did it, even though it's not written here. I like odd times odd cubed. Don't have to do this whole process. I actually really like this one that we did. It's moving around a lot. I like this one. And this would definitely get you the marks in the exam. Okay, we are nearly there. We're going to have a look at this last question. So 16, part 1 and part 2, they're not linked to each other because they don't say A, then B. It says 2 non-zero vectors A and B are such that the modulus of A plus B is equal to the modulus of A plus the modulus of B. And it says explain geometrically the significance of this statement. This does not just mean explain the statement and say the length of A plus B is the same as the length of A plus the length of B. We need to think about what this means in terms of the geometry. So I'm going to draw a sketch, okay? If I had a vector A and a vector B, then this here would be the vector of A plus B. Now, clearly, the length of A plus B, which is this, is going to be very different in this equation. In this scenario, it is not going to be equal to the length of A plus the length of B, which I'm going to show in a yellow here. The length of A plus the length of B is this and this. So this isn't true. Okay, at this point, the green length is shorter than the modulus of A plus the modulus of B. There's only one way where the green line can be equal to the two yellow lines. And the only way that that can be true is like this. If I have A and B, then if I added those together, it would actually be on top of it. It would be A plus B. So you can see here, there's my A plus B. There's my A plus B. The lengths of these are going to be the same when the vectors A and B are parallel. So the significance of this statement is that the vectors, let's get off this red color now, the vectors A and B are parallel. There are other words you could use to parallel. You could say same direction. You could say collinear. But I think parallel is probably the one that makes the most sense here. Okay, last question is obviously going to be a bit difficult, but let's see if we can do this. Two different vectors, m and n, are such that the length of m is 3 and the length of m minus n is 6. The angle between vector m and vector n is 30 degrees. Find the angle between vector m and vector m minus n, giving your answer in degrees to one decimal place. Well, this isn't really possible until you draw a diagram. So I'm going to start off with this sentence, and I'm going to try and figure out how I can draw it. So I have vector m and vector n has an angle between them of 30 degrees. So I'm just going to draw two vectors that are going to have an angle between them of 30 degrees. So here is m, and here is n. And we've also been told that the length of m is 3. And I now have been told something about m minus n. Now remember, if you have m minus n, that is the vector nm. It's the second letter minus the first letter. In other words, this is n and this is m. The vector m minus n is actually this one here. And that makes sense because you're going minus n to get along plus m. So it's this vector here has a length of 6. And we were told that the angle here is 30 degrees. So I'm just going to draw that triangle again, but this time I'm going to remove all of the letters. I'm just going to have the 3, the 6, and the 30 degrees. So I've got a triangle that looks like this, where I have 30 degrees. I have that this side is 3 and this side is 6. And the question wants me to find the angle between m and m minus n. M and m minus n. It wants us to find this angle at the top here. So this is the one I'm going to try and find out. Now, you're hopefully telling me that this is going to be using the sine rule. But for the sine rule, you need a side and an opposite angle. So instead of finding the red angle, I'm actually going to find this orange angle first. And then I'm going to find the red angle afterwards. So I'm going to do the sine rule here. So let me just call this angle down at the bottom, the orange one. Let me call this one theta. For the sine rule, I am going to say that sine theta over 3 from the orange pair is equal to sine 30 over 6. So solving this equation, sine 30 you know is a half. So that's a half divided by 6 multiplied by 3. So sine theta is a quarter. So I'm going to find out what theta is equal to. So it's going to be the inverse sine of 0.25, which is 14.47 degrees. And I want to find the angle that was in red that's at the top here, which I'm just going to call alpha. So to find out what alpha is, I would do 180 minus 30 minus theta, because it's just angles in a triangle. So that would be 180 minus 30 minus the one I've just calculated, which is 135.5 degrees. And I think they wanted it to 1 decimal place. So the angle between m and m minus n is 135.5 degrees. And I'm just going to check that that's the correct answer here. So there's, first of all, A and B lie in the same direction or equivalent. That's what OE means. So we got that with being parallel. Here's the diagram that we had drawn. Maybe it's a little bit different in the orientation to us. I'm not actually so keen on this one that they drew. I prefer the one that we drew over here on L1. We came up with the same working down here, okay? They've drawn minus n, but it's the same thing what we did, okay? So that's it. That's the end of the 2019 paper. I thought you might be interested to know stuff about the grade boundaries. Now, the grade boundary for an A in this, I think, was roughly 63%, and the grade boundary for an E was 30%, and I think it came up in increments of about 8% each time. So what would that be? 46%. And then a B would be about 54%. These are just the rough percentages. And because this is an AS paper, there was no A star grade because you can't get A star in AS. So it's kind of interesting to think that you may have gotten just over half of the marks and yet you still could get a B in this exam paper. It's a tough paper, but you've got to make sure that you're getting as many marks as possible to be able to hit those top grades. Well done for sticking all the way to the end, and I hope this was helpful.